Hello friends, now we will see one of the problem from assignment model technique. Now this assignment model technique, as we have studied already, that it is coming under the operation research, and this is one of the important model of operation research, whereby it is used to just optimize the given objective function. So given objective function can be of two types. It can be a maximization or it can be minimization. Based on that we are going to solve the problem. Okay, so to solve the problem of assignment model we are using Hungarian method. Okay, so basically we are using Hungarian method to solve this assignment problem. Okay, so this is the one of the method rather I will say this is the only method to solve the any of the assignment problem. Okay, so this assignment problem can be of any type. Okay, so it may be of minimization, so it can be of maximization. Okay, so it may be balanced or sometimes it may be unbalanced. Okay, one of the category of assignment model is restricted type assignment problems. Okay, restricted type assignment problems. Okay, so this any type of category problem can be easily solved by using this Hungarian method. Okay, so just some conversions are required to get the solution by using this Hungarian method. So this problem is given like this: a department has 5 employees with 5 jobs to be performed. Okay, so it is given as there are 5 employees in a department who are going to perform 5 different types of jobs. Okay, so the time in us each man will take to perform each job is given in the matrix. Okay, so is given in the effectiveness matrix. Okay, effectiveness matrix in the sense that depending upon the effectiveness, the time required for the particular employee to complete a particular job is given here. Okay, so how should the jobs to be allocated? Okay, so this is the problem of allocation. Allocation is nothing but problem of assignment. This is the problem of assignment of job to employee. Okay, and the assignment is like this: one per employee. That means one job is to be assigned to only one employee. Okay, so it is a one-to-one assignment so as to minimize the total man hours. Okay, so objective function is clear. This is the called as a objective of the particular problem. So it is clear that we have to minimize the total time required to complete the all 5 jobs. Okay, so there are basically 5 jobs A, B, C, D, E, which has to be performed by 5 different employees that are given as 1, 2, 3, 4 and 5. Okay, and these timings are nothing but the time required to perform particular job by particular employee. Okay, so for example, if I will consider this 10, it means that job A, when it is performed by the first employee, he or she is going to take 10 hours. When it is performed by second employee, he or she will take 5 hours. By third employee, 13 hours. Okay, and likewise for all the types of job, the time required by the particular employee has been given, and we have to decide a total minimum time required to complete all 5 jobs. Okay, provided that assignment is going to be 1-to-1, means one job should be assigned to one employee. Okay, now this type of problem, first we need to check out, is it going to be balanced or unbalanced problem. Okay, so one thing is clear that it is a minimization problem. Okay, so first thing is clear that it is a minimization problem. Second thing is that is it a balanced or unbalanced. Okay, so balanced and unbalanced means we know that balanced and unbalanced. Okay, so there is only one condition to check it, balancing and unbalancing. So there should be number of rows must be equal to number of columns. Okay, so 5 rows are there, 5 columns are there. Okay, so 5 rows and 5 columns, so it means given problem is a balanced problem. Okay, so we can move to the next step. Okay, so let's see how to solve this particular problem by using Hungarian method. Okay, so now Now it has been given like this: 5 jobs has to be done by 5 employees, and these 5 employees are requiring some particular time. That time has to be minimized. By using Hungarian method. Okay, so this is the problem given. So we'll see the first step. Now we know the first step after checking the balancing and problem function, that means either is it a minimization or maximization. We'll have to go for the first step. The first step is called as the row minimization. First step is called as row minimization. Okay, now in the first step, what is going to do in a row minimization, that we are going to select a smallest element of the row, and that we are going to subtract from the entire row. Okay, so here this is the 5, this 5 is the smallest element from the first row. We'll subtract it from each element of that particular row. Okay, so this is going to be 10 minus 5 at this place. Okay, 10 minus 5 is going to be 5. Second, 5 minus 5 is going to be 0. Next, 13 minus 5 is going to be 8. 15 minus 5 is 10, and 16 minus 5 is going to be 11. Okay, so this is the first thing that we have done. That means select a minimum from the row and subtract from the space that particular row. Okay, from the second row we have to follow the same process. Okay, so minimum or the smallest element is 3. Okay, we'll subtract it. So 3 minus 3 0, 9 minus 3 6, 18 minus 3 will be 15, 13 minus 3 is going to be 10, and 6 minus 3 is going to be 3. Okay, so these number will be like this. Okay, so from the third row, smallest element is 2. You can select either this 2 or this one or this one. Okay, is going to be same. So 10 minus 2 is going to be 8, 7 minus 2 is going to be 5, 2 minus 2 is 0 0 0, because same number is there. In the fourth row, that is row D, so smallest element is 7. Okay, so you can select this 7 or we can have this 7. Okay, so 7 minus 7 is 0, 11 minus 7 is going to be 4, then 9 minus 7 is 2, 7 minus 7 0, 12 minus 7 is 5. Okay, in the last row, smallest element is 4. When we will subtract it, it is going to be 7 minus 4 will be 3, 9 minus 4 will be 5, 10 minus 4 will be 6, 4 minus 4 will be 0, and 12 minus 4 is going to 8. Okay, so this is the first step, that is called as a row subtraction or row minimization, whereby we have selected smallest element from the row and we have subtracted it from that particular row. Right, now the next step is that we have to follow is column subtraction. Next step that we have to follow is column subtraction. Right, so now in the column subtraction, we'll see what to do in a column subtraction. So step second is column subtraction, or it can be called as column minimization. Okay, same, column subtraction, or it can be called as column minimization. Now whenever we are calculating next step, always we are taking the reference of previous step. Okay, so previous step is this one was the previous step, that is the first step, or row minimization. Now it is a column subtraction or column minimization. What we are going to do here, select the smallest element from the column and subtract it from that particular column. Okay, so smallest element can be 0 or smallest element can be any another. Okay, so let's check the first column first. Smallest element is 0. Okay, or this 0. Okay, so once we will subtract 0 from entire column, that column is not going to change at all. Okay, because 5 minus 0 is 0, 0 minus 0 is 0, 8 minus 0 will be 0, 0 minus 0 0, and 3 minus 0 will be 0. Okay, column will be as it is. It means if smallest element is 0, then column remains same. Here also smallest element is 0, so column will become 0, 6 minus 0 will be 6, 5 minus 0 will be 5, 4 minus 0 will be 4, and 5 minus 0 will be 5. Okay, in the third column, we are having again 1 0. Here we can find out, here is again 0, so I can write it here. 8 minus 0 will be 8, 15 minus 0 will be 15, 0 minus 0 is 0, 2 minus 0 is 2, 6 as it is. Again in the fourth row also there are 3 0, this one and this one. Okay, so value remains same, 10, 10, 0, 0 and 0. Okay, in the fifth column again there is a one more 0, so column will remain as it is. Okay, 11, 3, 0, 5 and 8. Okay, keep it in mind that now from this step you can easily understand that if there is a 0 in a column after row subtraction or row minimization, that column will be remain as it is, Okay, so row minimization is over, column minimization is over. Now we'll try to do assignment. Okay, so we have to draw the lines from the rows and columns such that all zeros will be covered and the number of lines should be minimum. Okay, and already as I had told that number of lines that we are going to draw must be always less than order of matrix, order of matrix. Okay, order of matrix in the sense number of rows or columns. Okay, so here order of matrix is of 5, so either our line should be less than 5, 4, 3, 2, 1, whatever possible. Okay, so if it is becomes equal to order of matrix, it means solution must be there. Okay, so let's check it out. Now from it is not compulsion that we should have to go first by row then by column. Okay, so you will have to go in a such a way that in a one stroke maximum zeros will be covered. It means if we draw one line, try to cover as much zeros as possible. Okay, so we'll see that row or that column where there are maximum zeros. Okay, so if you can observe third row, that is a C row, so there are 3 zeros. Okay, in fourth column also there are 3 zeros, so either you can go for third row or fourth column. Okay, so there we are going to draw a line like this. Okay, so it will be a dotted line, Okay, so here I have drawn the line through the 0. Okay, so these 3 zeros have covered. Now if I will draw one more line from the fourth column, these 2 zeros will be covered. Okay, so I will draw one more line from here, so these zeros will be covered, Okay, so which are remaining now? Here 2 zeros. Okay, so these 2 zeros can be covered in one stroke by drawing one vertical line, and only 1 0 is remaining. Now this 0 can be covered by drawing either vertical line or horizontal line. Okay, that will not make a matter. Okay, so I will draw horizontal line here. Okay, so how many lines we have drawn? Let's calculate it. This is the first line, this is the second line, this is the third line, and this is the fourth line. Okay, that means we have drawn only 4 lines and it is less than this. Okay, that means number of lines that we have drawn are less than order of matrix. Okay, 4 lines we have drawn, order of matrix is 5. Okay, order of matrix is 5. Okay, now let's see how to figure out next step. Now in the next step, what we have to do, we have to select a smallest uncovered element. Okay, now there are 3 categories actually. Covered means the numbers through which line has passed, that means this 8 is covered, 0 is covered, 11 is covered. Okay, so there is a one category of covered, another category of uncovered. Uncovered means the numbers through which the line has not passed, so these are called as uncovered elements. Okay, 6 and 15 and 3 are uncovered. Okay, this 4, 2, 5, 8, 6, 5, these are uncovered. And third category is crossed means this one. Okay, So here it is crossed, here it is crossed, means where two lines are crossing. Okay, so select the smallest uncovered element. Okay, so which is the smallest uncovered element? So this is the, so this 3 is smallest uncovered element. Okay, so this 3 is smallest uncovered. Okay, so no, okay, no, here is one more smallest element, that is 2. So 2 is smallest uncovered element, 2 is the smallest uncovered element. Okay, so we have to subtract this uncovered, smallest uncovered number from all the uncovered numbers. That means 6 minus 5, 15 minus 5, 3 minus 5. Likewise, we have to add it to the crossings, means here the line is crossed, so we'll add it, and we will make no change. There will not be any change where just line has passed. So 0 will be as it is, 8 will be as it is. Okay, so we'll make it. So number we have selected is 2. So at this juncture it is crossed, so it is 5 plus 2, 7. Okay, here it is only passed, so will be no change, again no change. Here it is a crossed, so 10 plus 2 will be 12. Here it is passed, so no change. Okay, again 0 as it is because the line has only passed, no crossing. Now here it is uncovered. Uncovered means subtraction. 6 minus 2 will be 4, 15 minus 2 will be 13, 10 it is just passed. Okay, so as it is 3 minus 2 will be 1, 3 minus 2 will be 1. Okay, 8 again it is crossed, so it will be 8 plus 2, 10, 5 as it is just line passed, 10 as it is just line passed, 0 again crossed. Okay, so 0 plus 2 will be 2, next 0 only passed. In the D row only line has passed, 0, 4 minus 2, 2 minus 2 will be 0, 0 only line has passed, 5 minus 2 will be 3, 3 will be as it is, 5 minus 2 will be 3, 6 minus 3 will be 3, 0 will be as it is, and 8 minus 2 will be 6. Okay, so this is how number are going to be there. Okay, so subtraction from uncovered, addition at the crossed, and no change at the covered. Okay, this is how it is going to be there. Now we'll try for the assignment. Okay, let's do it now. First row there is only one 0, so I will make the assignment here. Is there any 0 in that column? No. In that row? No. Second row there is only one 0, I will make assignment there. Is there any 0 in that row? No. In that column? Yes, so I will cross it. Okay, in the third row how many zeros are there? 2 zeros. Here is 1, here is 1. Okay, we'll come back because there are two options. In fourth row there are 2 zeros, we'll again come back. In the fifth row, that is E row, there is only one 0. Okay, so this is a compulsory option, so let's take out first of all compulsory options. Okay, so here I will make the assignment, but because of this assignment this extra 0 in that column will be crossed. But as I will cross this is already crossed, there is only one option in the D row, so let's take that option. As I will select this extra 0 in that column will cross, and as I will cross this 0, there is only one option in the third row and it will be selected. Okay, so this is like a chain, one by one it will automatically figure out. Okay, it will automatically figure out. So we can check out here now that wherever boxes has made, it means the assignment is there. Okay, now how to figure out this? A has gone to 2, A has gone to 2, it means here we have made the assignment, it simply specifies that A has given to 2. Okay, so A has given to 2 means A has given to 2 and its value is, we'll have to take from first original table. Its value is take from first original table. Okay, so first has gone to second, and the value we'll have to take from original table. Okay, that means the table that is a problem table. Okay, so this is the original cost matrix. Okay, and the value was 5. Okay, a given to second means here we have made the assignment, so it is a 5. Okay, then second b we have made assignment at the 1, that means here we have made the assignment. Okay, so and value is 3. B has gone to 1, value is 3. Okay, C, so for the C we have made assignment here, that means fifth column, and value we will have to take from here, the value is 2. Okay, D row assignment is at third column, so here is the D row assignment is at third column, that means 9. It is a 9. So D row third employee cost is 9, and next is E row where we have made given to the fourth employee, that job has given to fourth employee, and the cost or the time hours are 4. And if it has been asked to calculate total man hours, so these are 5 plus 3 8 plus 2 10 plus 9 19 plus 4 will be 23 man hours. Okay, 23 man hours. So this is the total time that has been required to complete all the 5 jobs by all 5 employees.